This is the 2011 AP Calculus free response, Part A, Question 1. And the question states, for t between 0 and 6, particles moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine of e to the t divided by 4 plus 1. The acceleration of the particle is given by a of t equals 1/2 e to the t divided by 4 cosine of e to the t over 4. And they also tell you that x of 0, which means when the position function is at 0, it equals 2. Part A asks, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. So right here I've drawn you, for part A, the graph of the velocity function, and really if you just, calculator is allowed in this problem, so if you put the velocity equation into the y1 and graph it, you can look at the graph and zoom in on 5.5, which I have drawn for you here. And if you notice right at that point right there, the function, velocity function, is negative and decreasing. Therefore, the particle is speeding up. If the function was increasing and positive, which means that velocity and acceleration have the same sign, it would also be speeding up. But if velocity and acceleration have opposite signs, the particle is slowing down. So part B asks you to find the average velocity of the particle for the time period t between 0 and 6. We can easily set up an integral from 0 to 6 with 2 sine e to the t divided by 4 plus 1 dt in there, and that is our velocity function. We also need to remember to bring on the outside the 1 over the 6, or divide the entire thing by 6, because it does ask for average velocity, and t is between 0 and 6. If we plug that into our calculator and use fnint, and use our given interval, you will end up with 1.949. C asks for the total distance traveled by the particle from t equals 0 to t equals 6. This is very similar to part B. However, we will not be dividing by 6 because it's not asking for the average velocity. We can set up a similar integral, 0 to 6, with the velocity function on the inside. However, this time we must use absolute value because it is total distance. And if we can remember, velocity factors in direction, and that's why we have the negative or the positive sign on the velocity graph, whereas with distance, we're just finding the total distance, not displacement that is traveled. So absolute value is a must here. And if plugged into the calculator in the same way, you will get 12.573 as your answer. Part D asks, for time t between 0 and 6 again, the particle changes direction exactly once. Find the position of the particle at that time. So we know that a particle will change directions when v of t, the velocity function, equals 0, and t equals, if you graph that and calculate the 0, you will find that t equals 5.196. We can go to the front of the calculator and store this value in a, and then x of a, we need to find the position. We do an integral from 0 to a of 2 sine e to the t over 4 plus 1 dt, which is our velocity function. However, we must remember to add 2 to our answer because it was given in the original problem that x of 0 equals 2. So 2 plus the integral from 0 to a, the velocity function, gives us 14.135. Thank you.